All right, good morning, happy Thursday. Today we're going to focus on how we can solve word problems using the four operations, focusing a little bit more on how to multiply large numbers using a little bit of area model. All right, so just to recap, if we have a problem that reads, that reads 5 times 17. Just a reminder, this is an example of an expression or equation. Expression. All right, it's an expression because it's not have an equal sign or an answer afterwards, okay? All right, so if I were to take 5 times 17, some of you are trying to do some of that mental math right now, but we're going to go ahead and show one more time what it looks like as an area model because that might actually help as a strategy when solving your word problems today. Okay? All right, so I know that off to my left is going to be my single one-digit number, which is 5. I know my 17, I need to decompose and split it up into that place value. So looking at my right side, value of 7, 7 ones. And that 1 in the tens place represents 110. So if you know what the place value represents and what that number represents in that place value, you can decompose and separate by place value. That expanded notation, right? All right, so I'm going to have 10 and 7. Okay. All right, so what I like to do is I like to put a little plus sign here because we just need to remember that it's not 10 over here, 7 over here just because, but it's 10 plus 7 that gives you 17. From here to here is 17, but we're going to separate it by its place value. Decompose those two numbers in order to find partial products for our total. All right, so finding our first partial product, again, partial means part of, product is the answer when you multiply, okay? So I want an area model system because it's going to help me break apart a large number into smaller numbers that I add together, okay? So the problem I'm going to have inside my first box is going to be 5 times 10. Think about it, is 50. All right, so this is one partial product. I can't leave an empty box, so I need to find out my other partial product. Okay, again, looking at the sides, which is, what is the distance from here to here? If it doesn't have a number here, I look here. Oh, no number here. Look here. Oh, this represents the length from top to bottom. So 5 times, you got top to bottom, I need across. So I don't need the whole thing across. That's why I split it, because I just want this section. I took a look up here. I have that, and it's a 7. So 5 times 7 is, think about it, 35. All right, I'm not done just yet. I have one partial product. I have the second partial product. Now, what do I need to do with these partial products? You said add them up. Nice job. All right, so off to the side, I'm going to go ahead and just take my total partial product here, 50, and add my other partial product. And starting with my ones place, 0 plus 5 is 5, 5 plus 3 is 8. 5 times 17 is 85. If you're comfortable with multiplying it standard algorithm just as is, great, you go for it. But an area model where you decompose and find partial products is another strategy that is helpful in case you need to break apart a large number to make it smaller and a little bit more workable for right now. Okay, working up to that. All right, now that we've reviewed this strategy, we're going to take a look at a word problem. Our first word problem goes like this. The baker uses boxes of different sizes to carry her goods. Cookie boxes hold 12 cookies. Donut boxes hold 4 donuts. Muffin boxes hold 2 muffins. And bagel boxes hold 6 bagels. All right. That's just some information we're going to need in order to solve the following problem. All right, so now using this information, our word problem is, on Monday, she baked 48 of everything. How many boxes did she need? All right, we're going to go back and forth to the information and the question itself to make sure we can answer this question. But remember, when we're looking at a word problem, we need to be able to understand and highlight, separate the information that is most important, and then just information that's there just to provide additional information about the problem itself, okay? So we're going to go ahead and underline any information that we feel is necessary to know and to understand and have highlighted so that we can answer and do our best work. All right. As we're reading on Monday, is that something I need to underline because it's very important for me to answer? Does on Monday tell me anything more about how many boxes she needs? No, it's just more information about the problem, something I don't necessarily need just yet, okay? All right, she baked 48 of everything. So does that tell me something I need to know? Does it have a number that is a part of my problem? Does it tell me what operation I'm going to be performing? Those are the kinds of questions I'm asking. All right, 48 of everything tells me some information that I need to know in order to solve. All right, and my question is, how many boxes did she need? That is what I need to restate, okay? All right, so if I have 48 of everything, I need to know how many boxes. So remembering that cookies, in each box of cookies, there can be 12 in each, okay? So let's start with that. So first, let's think about what kind of operation am I going to perform? So if this is a box, I'm going to let that represent cookie. That's my cookie box. And in my cookie box, again, how many can I hold? 12 cookies. I'm going to put cookie over here. I'm going to put the number 12 in here. Okay, this represents my cookie box, and it holds 12. So if she baked 48 of everything, so 48 cookies, 48 donuts, 48 muffins, 48 bagels, that's a lot of baking. But if she baked 48 of each, I need to know, just starting with cookies, how many boxes does she need just for cookies? Couple different ways to do it. See, some of y'all are thinking, oh, that's a division problem, or some of you might be thinking, oh wait, no, I can add it up or multiply. You know what? You can do all three of those things, really. Okay, but I'm going to go ahead and show you my visual thinking, what my thought process is like in my head as I'm thinking of this kind of problem. All right, so if I have 48, I need to continue to add until I get to 48. So if I have another box, again, this is cookies, with another 12, I need to keep track. Okay, so 12 plus 12 is 24, and I'm going to keep track so I don't go crazy high, okay? All right, and then another box, still cookies, 24 plus 12 would give you 36. Still not at 48. Here's another box of cookies that hold 12. 36 plus 12 would give you 48. Okay, let's pause right there. I have 48 cookies, exactly how many she makes just of cookies. I need to figure out again how many boxes she needs just for cookies. So how many boxes did we make, or did we need for all of the 48 cookies? 1, 2, 3, 4. 4 boxes. All right, so what I'm going to do is I'm going to erase this board, but I'm going to think about whether or not this is a strategy that works for me, or if maybe I need to use division because that is a stronger strategy. So maybe we'll alternate, okay? All right, so I'm going to go ahead and put off to the side cookies 4. That represents, for the cookies, we made 4 boxes for all 48, okay? And I'm just writing that off to the side. All right, next one is donuts, okay? Donut boxes, D for donuts, hold 4. If you're not sure, if you want to challenge my work, here you go. Donut boxes hold 4 donuts. All right, so I can do that same thing, what I just did, or I can think about it as a division problem. I know that there are a total of 48, Okay, she baked 48 of everything. So she did make 48 donuts. But each box will hold 4 donuts. So I'm going to put 4 into 48, and that will tell me how many boxes I need. 4 goes into 4. Yes, it does. How many times? 1 time. And I'm going to multiply. 4 times 1 is 4. Then I'm going to subtract. 4 minus 4 is 0. Check my work. It looks good so far. Bring down my 8. Does 4 go into 8? Yes, it does. How many times without going over? Twice. 4 times 2 is 8, and we subtract. 8 minus 8 is 0. Is there any number to bring down? No. Does 4 go into 0? No. So, no remainders, nothing else to be done. 4 goes into 48. Guess what? 12 whole times. So, that also tells me that for donuts, I would need 12 boxes for all 48 donuts. Okay? All right, we still need to figure out muffins and bagels. Here we go. All right, in order for muffins, we know that muffins will hold 2, they must be really large muffins, 2 muffins in every one box. Whew. So using the 2 strategies I can use, or using a third one, okay, lots of different ways to get there. I'm choosing not to do my draw the boxes because the number is getting smaller and smaller. That means I would have to make a lot more boxes. You're noticing that pattern there, okay? So I can either divide again or multiply. But in order to multiply, it would be 2 times something would give me 48. And this something would tell me the number of boxes. So I can look at this here. And if you're really fluent with your math facts, you might be able to figure this out. But if you're stumbling a little bit, I think the best way to go would be to do another division problem. 2 goes into 4, 2 times 2, 2 times 2 is 4, and subtract. Okay, check your work, looks good, bring down the 8. 2 goes into 8, 4 times 2 times 4 is 8, we subtract, and we're left with 0. Again, no number to bring down, 2 does not go into 0, 2 goes into 48, 24 whole times. You know what? If this is what your guess was, good job, but you still can check your work to make sure that it wasn't just a lucky guess. So in order to check your division work, 24 times 2. 4 times 2 is 8, 2 times 2 is 4. If this number matches this number, then your answer, your quotient, is correct. All right, so in order for muffins, we know that we have 24 boxes. That's a lot of boxes. All right. Last one is bagels. Our bagels will hold 6 in each box. Bagel boxes hold 6. All right, now we need to figure it out. All right, let's go back to that first visual because I think that might actually be helpful. All right, so 6, again, keep going. 6. We need to add it up as we go, otherwise you're just going to make so many 6s that you just can't keep track, and you go back and add them all up and you're like, oh, I made too many. So just keep track as you're going. Okay, 6 plus 6 is 12. Plus another 6 would give you 18. I'm just adding this because this lets me know that it's more like this number, okay? So it's that previous number with the new 6, okay? Explaining that again. So I'm not adding 6 plus 6, I'm adding 18 now plus 6, which is 24, okay? All right, let's take a look. Nope, not quite. So here we go. What we figured out on the last problem was that half of 48 was 24. So I can continue in this pattern, but what I can also do is know that this is half of 48. So if this is half of 48, all I need to do to figure out how many boxes of bagels is to double the number of boxes at this time. So if I have 4 boxes now for 24, twice that amount would be 8 boxes. Okay? Just thinking of all the different ways that you can reach your answer using different strategies, okay? All right, now we need to go back and make sure we have everything. Do we have 48 of everything? Yep, 4 boxes would give you those all 48. And how many boxes did she need? All right, a lot of different information. We need to still be able to restate that, okay? How many boxes did she need? She needed 4 boxes for cookies, 12 boxes for donuts, 24 boxes for muffins, and 8 boxes for bagels. Bam. That is how we restate. Okay? All right, we're going to do one more problem. I'm going to set it up. All right, so our next problem reads, on Tuesday, she baked just bagels. She filled 15 boxes. How many bagels did she make? Again, going back into the problem and understanding what information you need to solve this problem is really going to be a time saver for you. Otherwise, you're just going to go back and read this question over and over again without understanding what you need to pull from the word problem itself. All right, again, starting with on Tuesday. Does this tell us something that we need to know to answer our problem? No, it just gives us a little bit more additional information that is helpful for the problem, but not so much as answering the question itself, okay? All right, so we know that she baked just bagels. So she baked bagels and filled 15 boxes. I think those 2 pieces of information really do help us to figure out what operation, what numbers we're going to include to figure out how many bagels she made. All right, so the previous question was figuring out how many boxes, but for this particular problem, we need to figure out how many total bagels. Okay, in order to figure that out, we also need to go ahead and bring back to figure out how many bagels fit in one box. So bagel boxes hold 6 bagels. So if I know that in a bagel box, you can fit 6, okay, and she's already filled 15 boxes. Okay, a couple of, again, different ways to get to that. I can draw out 15 boxes and add them all up. 6 plus 6, second box is 12. 6 plus 12, third box is 18. I can do that. That would take a really long time, and I can do that. But is there a better, quicker strategy that would help me to figure out how many bagels did she fill, or how many bagels filled those 15 boxes? We can remember our patterns and rules. We can find a pattern. That pattern will help us to find a quick solution that is correct. All right, so if this represents 1 box, okay, does that kind of look familiar? What would it look like for 15? So what is the rule? Okay, kind of like when we did this. We needed to find a pattern and a rule. The rule was for every 1 minute, you multiply to 60 to get to seconds, and so on and so forth. So we need to find the same kind of rule. I'm not saying we need to look for 60. We need to find the rule that applies and makes it true. So if 1 box, okay, box equals 1 box equals, I'm going to write bagels, equals 6, okay? I need to know, just because that would stand for all the other numbers in between, what 15 boxes would equal. Okay, so what is the pattern that we can see becomes a rule? Okay, we can see that it could be times 6. Let's see if it works, okay? So if this were 2, and if I take 2 times 6, that would give me 12. And if I have in 1 box 6, and I have another box 6, I'm adding them up, and that would give me 12. So that does work. So what would be the rule here that applies? 15. So I would multiply. There's 6 in each box. 6 times how many boxes there are, 15. Okay, this is where our area model, finding those partial products, would really be very helpful. Okay, all right. I have my single number 6 off to the side, and I have my double digit number, and I need to decompose it. The 5 represents 5 ones. The 1 in the tens place represents 1 10. So 10. Okay, and multiplying to get my partial product. 6 times 10 equals 60, and 6 times 5 equals 30. Can't leave it like this. I still need to add my total. Okay, remember that these are partial products. It's a way to make it simplified and easier to find my big total number. So I'm going to add 60 plus 30, which would give me 90. All right, going back to the question. How many bagels did she make? She made 90 bagels. That's a lot of bagels, okay? Good job. And a quick pause. All right, one more problem, maybe geared towards something that we might be a little bit more familiar with rather than pastries. How about some change and money? All right, so I have a roll of coins, and these are nickels. Okay, if I have 6 rolls with a certain number in each roll, I need to figure out how many dollars I have. Okay, so I know that in this roll, I have 1 roll of nickels equals, okay, I see that it says $2 on there. $2 would be how many nickels though? You're already thinking 5, 10, 15, 20, 25. Okay, so thinking about quarters now. Okay, 25 is 1/4 of a dollar. Okay, so if it's 1/4 of a dollar, how many of those would we need? 5, 10, 15, 20 would give you $1. So if you have 20 for $1, double that for $2. And that would also equal 40 nickels. Okay, 40 nickels would give you $2. What other math operation could we do to check our work? All right, so if you're already thinking ahead and multiplying 40 times 5, 40 times 5, 4 times 5 is 20. That 0 means it's 10 times greater, okay? 200 represents pennies because it's all individual units, okay? So 200 pennies equals $2. So if you count it out, 200 pennies, it's the same as having $2. I would rather have $2 bills than 200 pennies, but that's just me saying that. All right, so here's the next word problem using some visual. I want to know how many dollars do I have if I have 6 rolls. So if I know 1 roll equals $2, how many or how much would 6 rolls of nickels be? All right, so we know that for every 1 roll, we have $2. That's finding that pattern once again. And we now have 6 rolls. We're multiplying the number of rolls and the number dollars to get our total dollars. So 6 rolls would give you $12. How do we know that? So we can count by our multiples of 2. 6 times 2, 4, 6, 8, 10, 12. Does that match up? Yes, it does. Okay. All right. So just a couple little review things that we're working on today, but making sure that we're adding, subtracting, multiplying, and dividing using any strategy to figure out how are we able to solve using our rule, our area models, partial products, in order to best help us solve using those different strategies. Okay, so today's assignment is just a couple of problems using very similar strategies that we've used today. If you have a different strategy like standard algorithm that you want to use, you go for it. Use the one that works best for you. Okay, do your best. Ask if you have questions. And I miss you guys. I know this was a long video. Thank you for sticking with it. Do your best. Rewatch, rewind, however much that you need to support yourself. Okay. Also know that you can just reach out to us. Okay. If you have additional questions that this video just doesn't answer for you, ask, and we'll definitely be wanting and willing to help you guys. Okay. Have a great day. Miss you guys. Work hard. Try and bang.